Hello friends, welcome to Nauru's CSC tutorial. So last day I had discussed a simple example on lattice, and I also had discussed the definition of lattice and the sixth theorem of lattice. Today I am starting with duality in a lattice. So what it is? In a lattice L, conjunction disjunction, the dual of any statement is defined to be the statement that is obtained by interchanging conjunction and disjunction. For example, the dual of the statement A conjunction B disjunction A is equal to A conjunction B disjunction A is the statement A disjunction B conjunction A is equal to A disjunction B conjunction A. So this is the dual of these statements, or just interchanging conjunction and disjunction, and we get this statement just by interchanging conjunction and disjunction. So this is the dual of the above statement. Now starting with distributive lattice. A lattice L conjunction disjunction is said to be a distributive lattice if the following two properties known as distributive properties hold. Like the first one, A conjunction B disjunction C is equal to A conjunction B disjunction A conjunction C. And the second one, A disjunction B conjunction C is equal to A disjunction B conjunction A disjunction C. So if a lattice holds these two properties known as distributive property, then the lattice will be called as distributive lattice. Now I am giving you an example on distributive lattice. So let's check this POset is a lattice, is distributive lattice or not. So the POset S consists of these elements 0, 1, A, B, C is lattice, which is shown by the following hash diagram. Here we know that two binary relation, conjunction and disjunction, are defined as A conjunction B is equal to infimum of AB and A disjunction B is equal to supremum of AB. And this is the hash diagram of the given POset. Now from the given hash diagram, B conjunction C is equal to infimum of BC. So let's check what is the infimum of BC. So infimum of BC, here B and C are on the same level, and the infimum of BC is 0. So clearly from the hash diagram we can see the infimum of B and C is 0. And A disjunction B conjunction C is equal to A disjunction 0. So this is supremum of A 0. So let's check supremum of A and 0. Supremum of A and 0 is A, because A is on the higher rank from 0. So clearly supremum of A and 0 is A. So here we will write that supremum of A and 0 is A. But A conjunction B A disjunction B conjunction A disjunction C is equal to 1 conjunction C, because supremum of A and B is 1 and supremum of A and C is C. That is why 1, here the conjunction C. So infimum of 1C is equal to C, because 1 conjunction C means infimum of 1C, and that is C. Clearly this shows A disjunction B conjunction C not equal to A disjunction B conjunction A disjunction C. So this lattice S is not a distributive lattice. So clearly this is the conclusion.